Hello friends, welcome to Science Gallery. In our preceding lessons, you have learnt about electricity, potential difference and what exactly the electric current is. In any electric circuit, current flows by any electric source. This electric source supplies the current in different components of the circuit, but this current does not flow through these components in same amount. Some components do not allow to flow this electricity easily through them. That means they protest or restrict the current flow, so full amount of current supplied by the source does not flow through these components. When we measure the amount of current through these components, the ammeter shows low reading of current. That means less amount of current is passing through them, while on the other hand, some components show higher measurement of current. That means they allow the current passing through them easily. Let's see this with the help of an activity. If we attach a piece of nichrome wire in this gap XY and switch on the key, the current will start to flow through the circuit, which we will measure with the help of ammeter. We find that ammeter is showing the reading of approximately 1.8 ampere. Now we will replace the nichrome wire with a 10-watt bulb. After putting on the key, we will read the reading of ammeter. It is approximately 1.5-1.6 ampere. Now after replacing 10-watt bulb with a torch bulb, we will again switch on the key. We will see that the bulb will glow the brightest. Most probably, it may burst because a high voltage current passes through it, which it may not bear. You can see by yourself that the ammeter reading is different for different components. Why does it happen? Why a different amount of current is flown through the circuit by the similar electric source? Certain components let flow the current easily, while some others resist the flow. If in any circuit, a component is connected which gives easy path for the flow of current or does not resist the current, that time the ammeter shows higher value of current, while with the component which resists the flow of current, ammeter gives low reading. That means low amount of electricity runs if any resistance offering component is connected to any circuit. Now the question arises, why some components resist the flow of current while some others help in flow? We all know very well that some substances are made up of elements which tend to lose electrons from their outermost shells because the electrons of their outermost shells are loosely bound to the atom, and it takes a very little energy to kick them off to move around freely across the atom. These freely moving electrons are known as free electrons. The substances which have good number of free electrons in them are good conductor of electricity, while on the other hand, the substances which have lesser number or don't have these free electrons, they don't conduct the flow of electricity very easily. Because of lack of carriers of electricity or free electrons are known as non-conductors. A non-conductor does not let the current flow through the circuit or through any medium because it restricts or resists the flow of current and its resistance is maximum, while on the other hand the resistance of good conductor is negligible or of very low amount. Some conductors offer an appreciable or favorable amount of resistance, that means neither very high nor very low. Those are known as resistors. So in this experiment, ammeter reading was changing with every component because of the resistance offered by them. The ammeter reading was high with the component which was offering low resistance, and the reading of ammeter was low with the component which was resisting it. So by now you must have understood the connection between current and resistance. In our next video, we'll learn about some more interesting topics and phenomena related to electricity. Till then, take care. Bye-bye.